Welcome to the session on augmented reality and virtual reality. So my name is Pascal. I'm the director of the Esri R&D Center in Zurich, Switzerland, where we develop CityEngine, the 3D JavaScript API, ArcGIS Urban, and also the virtual reality solutions. Then with me is Eric Wittner, who is the product manager for ArcGIS Urban and CityEngine. Then there is Adrian, which is one of the lead developers in the ArcGIS Runtime team, and Rex, product manager of ArcGIS Runtime. I'm going to talk first, kind of give an overview of like what are our definitions and kind of just general introduction into the whole world of immersive computing. Then afterwards, Eric will show some of our solutions, of our apps. And then afterwards, the Runtime guys will show the amazing development environment which we are building for you for augmented reality applications. So let's start. First, definitions. So virtual reality, what does it actually mean? When we say virtual reality, we mean, I think in the meantime everybody knows, like the Oculus Rift thing, which became famous. In the meantime, it's these gloves which you take, and you are completely immersed in your world. And especially, for example, for urban planning, where you actually really have things about, where you actually really need to immerse in things which have not been built yet, this is a good application. Then, augmented reality. This is Adrian. Augmented reality is, how we define it, is with phones. So means you take your phone and your phone knows where you look at, and the camera is on, and it augments your camera. So you see here a video of. Rex will talk more about it afterwards. You see here an indoor navigation video where actually really reality is augmented. So you can walk around, and it knows, the phone knows where you are, and accordingly, it really helps you to get around, and it navigates you around. So it means in our terminology, when we at Esri talk about augmented reality, we really mean mobile devices, and like mobile or tablets. Then the other thing, which is called is mixed reality, and this is here we are using basically the terms of Microsoft, and that means the HoloLens and Magic Leap are these kind of devices. So it means they are, again, these kind of devices, but this time, they are see-through. So here you see an example from the city of Zurich, where you actually can go in, and so you are on site, and it's kind of a mixed reality experience where you see what will be built in the future. Or the other famous application for mixed reality is, for example, when you are actually really standing on top of a street and you can see the utilities below the street. So mixed reality means basically HoloLens for us. So at Esri, we have solutions for all of these applications in different ways. So basically, what we all have is we have lots of GIS data, and we somehow want to bring this into these different media. And so what you see here is basically our offering currently, which we currently have, and you can take the GIS data, and then there's the ArcGIS Runtime. So that's what Adrian and Rex will talk about for developing these AR applications. And then for other applications, we have CityEngine as kind of like gateway tool where you can import the GIS data and then export it to either ArcGIS 360 VR, which is a mobile VR application, or the CityEngine viewing experience, which is kind of a premium VR application for the HTC Vive and Oculus Rift. And then we have CityEngine as a gateway to, in general, transform GIS data into game engines like Unity or Unreal. So the thing is, just to give you a bit of background and feedback, the challenge in immersive computing is the positional tracking. So two terms which I think are important to know is one is called outside in and the other one is inside out tracking. So means if you have outside in, that means there are markers, and so means you have a complicated setup. You need to place markers. So the HTC Vive is the famous one. And the advantage is you have controllers and everything in a very good way. But then you have inside out, and inside out means you have the cameras on in your head gloves. You have the cameras in your glasses looking outside, and so they basically track where you are and figure out where you are. The problem is the controllers don't work so well, so these cameras need to somehow connect with the controllers. But the big advantage is really of this inside out is that the setup is so much simpler. So what we currently we have this premium VR offerings, which are the HTC Vive or the Oculus Rift, and they are with markers, and they have this so-called 6 degrees of freedom. So it means you can rotate and also walk around, and they track everything. And they have really great graphics. So the graphics they are connected to a PC. However, you have a cable, so some people don't like to having this cable. On the other hand, mobile VR, that's this one here, is very simple. You don't need a setup with markers and everything. The problem is these guys they have the whole 3D engine is basically inside the glass, and so you cannot really the headsets cannot really. They can have a big NVIDIA graphics card inside, of course. And however, I think what we currently see is that these two kind of merge together. I think in a year we only will have inside-out tracking. I think in 2 weeks Oculus will probably introduce a new headset which has inside-out tracking, and they stream the graphics and everything. So I think this is going to this distinction is going to disappear. Then the other challenge is actually when you have for mixed reality, you always need an initial position so that you actually know, like, okay, so this is my table. So you need to kind of figure out, okay, is this the table, and everything is related to this point. So especially when you have something like here, where you have an experience with like multiple people looking at some virtual thing together. So you see here Jack and Scott looking at some 3D model in the city of Zurich. And you see here the marker. So everybody had to first look at this marker so that it gets basically set up. The other problem is actually then the global position tracking. So maybe you don't remember anymore these guys, the Pokemons, but the very first version, these guys were like somewhere that they were like really geolocated. However, they were not like really accurate because it was just using GPS. However, when you now look at the stuff which Google is doing, where they have actually really accurate, also extremely accurate augmented reality solutions, which actually, because they can use all their street view data and all the stuff, they have an extreme accuracy even outdoors. But the problem here is really that GPS outdoor is still like kind of a 10-meter accuracy, and only inside you can use beacons or whatever to have a better position tracking. This is also, yeah, maybe you heard, we acquired this company indoors, and this is also for tracking inside, to have better tracking inside. But in general, for augmented reality applications, the big problem is this global positional tracking. So now I want to talk quickly about the user interfaces. So this is actually something which also, like, because the whole immersive computing is very new, it's not yet clear how you interact with these things. And one of the things which kind of start to converge to is this so-called tabletop user experience, or some call it also table scale. So it means you have a table, it can be on a virtual table, or it can be on a real table, and then you have on top of this, you have the 3D model. Then you interact on this table on that. Good thing there is, like, you don't get motion sickness because the table is there, and you are used to something, to interacting with something which you know, and it's just like one of these user experience patterns which kind of goes through very rare. So which kind of, I think, converges to. Even here you see, for example, these guys play a game sitting around the table. Kind of looks a bit weird, I think, but yeah, you see that the tabletop is not just something for urban planning or something. It's really a very generic user experience pattern. Here is our VR experience. So this is the CityEngine VR experience, and you see this is for 2 people. And here you can basically, what we provide is with CityEngine you can import your data into this experience. And the thing here is, like, what we kind of experienced was that we gave people 2 controllers, and for example, this is something which most people cannot deal with 2 controllers. They are already the whole VR thing, they are so excited about it and overwhelmed, and then you give them two controllers, and each of these controllers have 5 buttons. So it's like flying a jet or something. So it's not good. So means I think what's something which we did, for example, was there, like, that you only that you need to build an experience, and then you use only 1 controller. And even for HTC Vive, for all these things. Same thing goes for example, the new headsets. So for example, Oculus Go comes with a controller, just with 1 controller, very simple controller where you can interact in 3D and press 1 button. So it's really like people need simple things. And this is really something where we kind of see things are converging there, like it's really getting these user experience patterns. Here you see the HoloLens 2, and then the other thing, so means here you see hand tracking. So this gets better and better. Maybe you remember the HoloLens 1 was where people doing this thing. So this now gets much better, and it's very intuitive. Then you grab stuff and move it around just with your hand. And you see, what's actually really cool with the HoloLens 2 is, I think what they kind of realized that they also have to deal with the widgets. So it means in VR, AR, MR, it's still not clear yet, like, how do the buttons look like? How do the sliders look like? How do I interact? How do the menu? Where is the menu? All these kind of things are not solved yet. So, and this is, I think these guys thought really about it here. I think this is the first time I kind of, you see a company actually really thinking about this in a generic way. And here you see, for example, how she's using the slider. And And I think it seems to be very, very intuitive. Also something because there's no audio, what's also, of course, there's natural language. So it means you can control with natural language the user interfaces, or here the buttons and all these kind of things. So I think HoloLens 2 comes with these kind of widgets, which are pretty amazing. And then also here you see this is the other trend, is eye tracking. So just by looking at the bottom of the virtual screen, it was scrolling here. So again, let's see it again. So, so this is something also which I think HoloLens 2 will be the first kind of big mass device which has eye tracking. So this will be a very interesting thing. So what I want to say here is like the whole UX, user experience and user interfaces for immersive computing devices are still kind of in the making and very, very young. And this is actually very exciting times for developing applications around in this space. So back to the overview here. So again, you see here the different offerings we have at Esri. There will be more come. And now I give the word to Eric, who talks about ArcGIS 360 VR.
Thanks, Pascal. So ArcGIS 360 VR is a mobile offering for VR. It's created from CityEngine, and it's designed to be used on lightweight mobile devices as a way to get VR into many people's hands very, very cheaply. I actually have an example here. So if you're interested in giving it a try after the session, just walk up and you can take a look of an example of a 3D building with interiors and electrical and water, and you can strip away the walls and look at it from different perspectives. So the reason we're interested in kind of creating this lightweight, easy to publish experience was to enable urban planning so that people could look at designs that they couldn't get to in the real world or because they didn't exist yet. So you could actually look at multiple examples of a proposed building. The idea is to make the immersion in a virtual reality experience as easy as possible. Oh. Okay, now you can see. So yeah, so this is the ArcGIS 360 VR. So the whole idea is to make creating VR, create an immersive experience as easy as possible. And we want to put the world in perspective so you could look at the future designs or past designs quickly and easy. Our focused work cases, right, is a simple demo that we can take multiple scenarios inside an urban environment. So this is an example from the city of Zurich. They have a proposed building. They've exported it, brought it into 360 VR. They have a selection of different alternatives. They've got multiple perspectives authored that the person can look at these, right? And very, very quickly, they've created a way that they can flip between, and the person can say, okay, from my apartment, what is this proposed building going to look like? Is it going to block my views to the green space on the other side of the railway, right? And then they can swap in the alternatives to see it. It's meant to be very simple to create and very easy to use. It's a new format that we created at Esri, 3VR. Really what it is under the hood is just a series of spherical imagery that we've captured from multiple perspective points inside of a 3D software, in this case CityEngine. We've kind of cataloged those and curated them based on location and based on scenario, and you can jump between them, and it gives you kind of two things. One is it gives you this illusion of movement because you can jump to multiple perspectives, but it takes away the acceleration that tends to make people feel queasy when they're in another immersive experience. It's authored from CityEngine. It's really, really simple. You just create a set of bookmarks and publish, and then you share that item onto ArcGIS Online and consume it in the app. So as I said, really under the hood, right, it's just a representation of imagery for different perspectives that you're jumping between wrapped and this structure that allows you to access it. So anything that you can bring into CityEngine, you can publish there. We've targeted urban planning, but other people have been using it to do historical exploration or utilities visualization. But very simple, CityEngine, publish to a 360 VR, upload to the cloud, and then consume in the mobile device. And let's just take a look at what that authoring process looks like, right? So I'm inside CityEngine here. I've got a scene with a set of 3D buildings. I've defined my views as bookmarks of where I want to go. What I'm looking at is my initial perspective, right? And I just go File, Export as 3VR, select the bookmarks that I'm interested in. If I have multiple scenarios, select which scenarios I want to be included. Press go, and I get an item type on the back end, and I can push that up to ArcGIS Online. Right now, it's an Esri Labs project, so you have to go to the Esri Labs page, sign up to get access to it, and then we'll send you a code, and then you can download the app on the Oculus Store, install it on your device, and then start using it to consume items. There's actually a fair number of these 360 VR experiences published on ArcGIS Online already that you can look at. So here is actually where Pascal works. This is the Zurich R&D Center that we've built a 3D model of inside CityEngine. So rules that represent the furniture, the walls, etc. We have different locations captured inside the building. We export that to a 360 VR. In this case, I'm viewing it in a little prototype web viewer, but I'm trying to give you a sense of what you would see if you were looking through the goggles. So I can pan around, look with my head. The little blue dots are the locations that I can move to. Look like little cameras with views in a view direction. Click on one, jump to it, look around, and that allows me to navigate around this environment and see kind of different parts of it. And if I had multiple scenarios, I could flip between them. So right now, it's kind of in maintenance mode. We released a slightly new version with 2018.1, which fixed some bugs. We added support for Oculus Go. We're adding some more fixes with the next CityEngine release next month. It's still not available generally in the Oculus Store, so you have to go through that lab experience. And we're looking at WebXR as a way to make a web browser-based version of this in the future. I also wanted to just briefly on one other mobile app, which is ArcGIS, which is another Esri Labs exploration, but it's focused on augmented reality. So we heard a lot of feedback that people wanted to do more than just bring points into ArcGIS in the future. So it's been kind of in maintenance mode for a while, but we're actually looking at the next generation of this app, being able to consume a broader type of information, lines and polygons and 3D models, and actually kind of make it more of a storytelling tool in the long term that kind of has more robust uses. So yeah, so with that, I'm actually going to turn it over to Rex and Adrian to talk a little bit about the runtime and how that can be used.
Great, thanks, Eric. All right, so now we're going to talk a little bit about working with extended reality for developers. And we'll be focusing on ArcGIS Runtime, but think about this a little more broadly than that. Initially, we'll focus on Runtime because we have some experience in that area. But we'd like to think a little more beyond just a native application and look at some of the other technologies that are associated with building out developer solutions. So the first thing I want to start with here, just to get us on the same page, is to talk about the extended reality spectrum. And this really builds on top of what Pascal talked about a little bit earlier today. Really puts it into one slide that talks about how we can take our current physical reality and blend that most effectively with a digital reality, or maybe let's say digital content. And so along this mixed reality spectrum, we're going from things like presence, where we honor location and where we are and what we're looking at, to teleporting to another location, a digital location, and actually experiencing that immersive experience with the help of devices and capabilities. So if we start to look at how different forms of reality spread across that extended reality spectrum, we see augmented reality on one side in your physical reality. This is where we start to supplement our physical experience with virtual content. We augment our experience, right? So there's still a presence, location matters. We want to be able to respect that location, whether it's a small scale or full scale experience. And as we start to move to the middle of our extended reality spectrum, we get this perfect blend, this premium experience of mixed reality, which is a holographic experience. We can use both of our eyes to be able to place and honor holographic content, digital content in space. And we can really work with that more immersively. On the opposite end of the spectrum, we're looking at virtual reality. So being able to teleport to another location and experience that digital content as if you were there, right? So true immersion. Now there's some initial interactions here that might involve just being able to basically teleport to a location and get some initial experiences there, maybe 3 degrees of freedom. But as we start to move to the middle or to the sweet spot within this extended reality spectrum, we get a premium VR experience. 6 degrees of freedom, where it starts to honor our movements up, down, side by side, left and right. And we have a more immersive experience in that remote location, in that virtual location. So what we find across the spectrum is a set of devices. And if we work on if we look at the augmented reality side and the virtual reality side at the far ends of the spectrum, we'll see things like mobile devices, mobile phones or tablets. And this is where we're just entering into this experience, right? We're just providing a simplistic or a simple experience. And as we start to move to the center, to the middle, to our sweet spot within our extended reality spectrum, we start seeing premium experiences, whether it's a holographic experience where we're able to supplement our physical reality with true holographic content, or a virtual experience where we can honor our movements in virtual space more realistically. A couple things that we've noticed when working with customers along this spectrum is that many organizations have a lot of content, a breadth and depth of 3D content, and they want to be able to leverage that content, both live and local, their authoritative content and analytics in this extended reality spectrum for a variety of uses. A couple things that come out with respect to critical needs for usability. With virtual reality, we need to have a high fidelity experience, right? So you don't want to make people sick when they're working with your content. You want to make sure that they can work with it effectively and have a good experience, a good responsive experience. With augmented reality, we need to honor positional accuracy, the location that you are and the orientation that you're looking at, and make sure that that maintains constant or is as accurate as it possibly can be. And the synchronization of both virtual content and usually a camera feed that represents physical reality are overlaid appropriately and respected. Of course, both of these must be cost effective, right? So being able to distribute these experiences in a cost effective manner is critical for businesses. So a couple things that we see, just market trends in general. This is one market trend graph that we saw from DigiCapital. This shows some of the trends within really across the extended reality spectrum, virtual reality and augmented reality. What we're really highlighting here is the fact that augmented reality is going to be significantly greater, at least from the market possibilities, than virtual reality. And that augmented reality on devices that are already in someone's pocket, that people already use today, will probably drive a lot of these experiences. So being able to work with mobile phones and tablets to experience an augmented reality experience, to provide or deliver an augmented reality experience, will probably be some of the first experiences that folks have when being able to work with or augment their physical reality. And so we see a lot of that, a lot of the forecasts in this area. Of course, if we're looking at focusing on enterprises and enterprise capabilities and different markets that we want to be able to look at, what we find here is there's a lot of different industries or organizations that are looking at using augmented reality in a variety of ways. Whether it's defense and intel, it's utilities, it's education. There's almost an equal spread across all these different industries with respect to leveraging augmented reality in these technologies. Of course, there are different applications for that, but we see a fairly pervasive and consistent need. And this is really representative of a lot of the different metrics that we see in the industry today. So that was a general sort of view of extended reality across the market. What do we actually see as market trends in GIS? And we're really tackling this right now from a developer perspective. What are developers looking to be able to build out? What solutions are they looking for? From the AR or mixed reality experience here, we see a lot of folks being able to accent or enhance their field operations, utilities in the field being able to look at assets and interact with those assets more effectively, resource management, folks that are working, let's say, in natural resources that are able to go into the field and evaluate and report back information about whether resources are available or what the impact is of different operations on resources, as well as planning, being able to visualize plans in the field, as well as plans in the back office and share those or collaborate with others around a common sort of virtual representation of those plans. Obviously, a lot of folks are looking at handheld. A lot of customers are looking at building handheld experiences. Existing mobile devices is key here, really enhancing existing workflows. So not changing workflows, but just enhancing an existing workflow. When let's say an employee goes or a field worker goes into the field, they have a workflow today where they might be gathering information. As they're gathering that information, they might be using a form. What we find is that in order to introduce that field workforce to AR, we supplement those form-based workflows or map-centric workflows with an augmented reality view. And that tends to introduce folks that are in the field that are working with geographic information subtly, but usefully. And so we find that being able to introduce this slowly, finding an initial ROI that works for a number of different industries is probably the best way to introduce AR, leverage existing devices, and allow those devices to really work for the customers and for their workforce. We are seeing some needs here for head-mounted, think premium AR devices like HoloLens or Magic Leap, and being able to work with these both in the field at full scale or in the back office with maybe a tabletop or floor top experience with models. Granted, it's nice because generally they're hands-free. Right now the technology is still kind of still advancing so that we can find things that are truly wearable. Right now most of these devices aren't truly wearable. You put them on with purpose. But we'll see that, we'll see the size and the weight start to diminish and the quality and the field of view improve over time. But this really provides the most immersive and collaborative experience right now because it provides a true sort of holographic immersion enhancement to physical reality. And so we see some folks asking for this. Generally these are game engine driven capabilities. But we begin to see as the hardware itself begins to catch up more demands in this area. In VR, we found a lot of folks are looking at being able to use VR for education. Able to teleport someone to a different location, maybe on the surface of the earth or just off the surface of the earth to be able to illustrate or provide some sort of feedback on a specific phenomenon, such as climate change. Planning is another option, being able to teleport or take someone to another location where maybe a new building or new structure is being built out. Be able to show from different perspectives how that looks and feels. This is similar like what we saw with 360 VR before. Training is another one, which is being able to take an individual and put them in a situation, in a location, and be able to get some feedback on how they would react or what they should look for when they're actually on site. So obviously mobile, being able to target mobile devices, easy, cheap to redistribute. Someone has a mobile phone in their pocket, providing them with a VR experience on their mobile phone is easy. All you need is a headset, Google Cardboard for a couple of bucks, and you're good to go. Granted, the experience there is driven primarily by the device itself and device capabilities, so it can be somewhat compromising depending upon performance. Desktop-driven experiences. Right now, granted, there are some mobile experiences that are targeting a premium VR experience, but in most cases, if you're working with a Vive or a Rift, you've got a powerful desktop behind the scenes, and it's driving these premium VR experiences for really a full immersive experience with your virtual content. So we see a lot of needs here in a variety of different areas. So how are we looking to meet some of these? Well, the first one is we already have a product called ArcGIS Runtime. ArcGIS Runtime includes a set of native SDKs. So as a developer, you can build out solutions today using a language of your choice, a native language of your choice, C#, Swift, Java, whatever you'd like. Currently, Runtime supports 3D, and being able to support 3D means being able to provide a 3D perspective on a flat screen. So because it's already supported on all platforms and all devices, we want to be able to leverage the capabilities that Runtime has today, right? As a native app, we also support integration with sensors and controllers, and so being able to work with sensors on devices that allow you to provide a great extended reality experience is something we want to be able to leverage. So what have we done? Well, so we've provided a beta. We have a private beta today with ArcGIS Runtime. This private beta has been in place for just a little over, well, almost about a year and a half at this stage. And we've been gathering feedback. We've got about 250 customers in the private beta providing us with feedback, giving us information as to what they need going forward, working with our iOS, Android, and .NET SDKs today. Actually, just a little mention there at the bottom, if you'd like to join this private beta, feel free to send an email to this alias and we'll get you in the program. What we found in this year and a half is that ArcGIS Runtime, as it is architected today, is really best for augmented reality on mobile devices only. Not only that, but we want to be able to target iOS and Android devices as mobile devices because they provide a toolkit, really capabilities that we need to be able to leverage to provide the best augmented reality experience we can. And that means phones or devices that include support for ARKit and ARCore. And so that's what we're looking at targeting as we're going forward. Runtime can meet this need, and that's one thing that we're going to be looking at supporting in the near term. This is it's not for VR or mixed reality. It's not for premium experiences right now. The rendering pipeline that Runtime has been built for is very sophisticated. It's designed for really sophisticated GIS capabilities and operations. We're enhancing, of course, those with an augmented reality experience. And so we'll be looking to release this later this year with an update to Runtime. So Runtime will have an update this summer. We're going to be providing a toolkit component that allows you to enable AR capabilities within Runtime. That toolkit is, of course, open source, so you can see our use of ARKit and ARCore behind the scenes. You can take advantage of this. You can manipulate it. You can change it. As a developer, you can utilize what we provide. One key factor there might be the ability to provide better location, as well as orientation capabilities too. So being able to tap into different sensors and other resources that are available to give you a better location. And so one of the reasons why we're providing that as an open source toolkit component. So you'll see that light up later this year. In the meantime, we've had a couple of examples. I'm just going to play a couple of them here. We've got a couple slides of examples of what folks have built. This is an example here of building a navigation app. And so using our Runtime SDK, AR capabilities, we're typing in a name of a person, and this is actually at Esri headquarters back in Redlands, and we're going to be able to find out how to get to that location once I know the office number. And so in this case, we're navigating through the foyer here, through the hallways at Esri, to be able to find, using the arrows that have been drawn based on a route that's been calculated through the building. So we have a network of the building. We found the location. We have a route and a network, a graphic basically that's been drawn on the surface. That surface is rendered as part of Runtime and then shown on top of a camera feed, all as part of our Runtime SDK to provide an augmented reality experience here to get from one place to another. So really kind of a heads-up navigation experience on an existing mobile device. So a great example here, we can get a little reflection of Adrian, I think, there, as he's trying to find his way to his boss's office. Is that right? Okay, there we go. Great stuff. So there's a good example of a solution that was built with Runtime that we have today. Let's take another example here. This is an organization working with our Esri UK distributor called RNLI. They work with, they're actually a nonprofit agency. Their purpose is to be able to gather information about incidents that occur off the coastline of the UK. And as those incidents are reported, and they'd like to provide this to citizens, an application that allows citizens to report those incidents back to RNLI, they can dispatch emergency services, right? So this is a quick example here of a citizen engagement experience that is easy to build and easy to distribute because citizens are using their existing devices, their existing phones to be able to go into the field. Another example here is we've been working with a couple of our distributors to work with local utilities, and in this case, some local water and gas utilities, and being able to show, working with or visualizing some of those utilities, those networks, lines, polygons, points, symbols, models, labels associated with their utility network in an augmented reality space. And so what we see here in the video is being able to visualize really water infrastructure under a city. This happens to be from our Esri China distributor, and they were working with a local city there to be able to visualize as they move through the city different parts or different assets within their utility structure. So great to see some successes here. Of course, this is draped on top of the ground. There's a variety of different techniques for being able to represent these on a flat screen because we don't have a stereoscopic view. So depth can be an issue. So sometimes draping these on the ground is most effective to determine where it intersects with where you are. So something to think about. All right. And this last one, before we dive into a demo, is, again, this is Adrian, all-star developer, here about ready to take the stage. He's on the stage. This is a video from last year. We were on the plenary stage, and Adrian had built out an AR application that allowed for really a tabletop, or think of it like a floor top view of downtown San Diego. And so, of course, the key here is that we're using a device to be able to visualize this content on the ground. Of course, because we're using the device and we're honoring the location of that device, as we move through that content, we can just merely move the device. We can move our body. And as the phone moves, we honor the location of that device and the location of the content. So to move down, you nearly kneel or crouch. To move sideways, you walk sideways. To move forward, you walk forward. And you can interact with this digital content as if it exists in reality, right? So what's interesting about this is that we're really leveraging what Runtime provides. So Runtime provides the ability to access a variety of different data sources, including 3D content. We're working with 3D objects here. These are buildings, textured to look like, obviously with individual textures to make them look photorealistic. We're also going to be showing collaboration here shortly. So I show up on stage as a prop, actually here. I think I get my 1 second of fame here shortly. And so Adrian wants to see where I'm walking, right? He also wants to see what I'm looking at. And so what we're doing here is we're using just a messaging protocol between the two devices in this case. And you can see my avatar there as I start walking around the city. And what he wants to be able to do is enable a view that shows the view shed from my perspective. Like, what can I see versus what can't I see? And so if he flips on the view here, what we'll see here is that things that are in green are things that I can see. Things that are in red are things I can't see. And he can really have a more interactive experience with where I am within the model, what I'm looking at, and really gain more information or gain more insight into what I'm doing as I start to interact with the model and what I'm using, or what I'm looking at. So there's more of a better close-up there, actually. Great. And with that, I'm going to hand this over to Adrian, and he's going to take us through a live demo. Good stuff, Adrian.
Thank you, Rex. So yeah, we are at a developer conference, so there's even better than all those AR, VR images. It's just lines of code, right? So when you join the beta program, you will just have access to that website that has a lot of video explaining what you can do, and especially bits to download. So as you can see, we already have 3 betas, and the last one targeting Android and iOS. What it looks like when you download them is you do have basically documentation explaining on how to use that SDK. And you also have just a simple app that you can just build and run, and you won't have to write any line of code, and you will have done your first step into augmented reality. Let's have a look at the source code for this really simple application that comes with the beta. For runtime developers, those are fairly simple, and they will recognize most of the API there. So I'm just creating a scene, and I'm just saying that my background is going to be clear, and I'm adding just one layer, which is the San Diego textual building. And I do say that my particular scene view is going to be an AR-enabled experience. And then it's all about just making sure that my camera, which is going to basically where the 3D content is going to be drawn from, that camera needs to be controlled by my device. And to do this, we have the notion of a motion data source that's going to be connected to my phone, and we just connect this to our ARKit motion data source. So in that particular example, we're going to use ARKit. So that sample is, really only a first step into augmented reality. If you can move to number 1. And so all you have is basically the San Diego building sitting in my scene and reacting with me turning my phone. So something really simple, doesn't look really realistic yet, but that's just what's out of the box available. All the documentation on the beta website is for all the API that is specific to AR, VR, or AR in that case. But everything, all the other APIs is basically already in the runtime. So you can just go to the developer website and have all the information you need for all the capability of the runtime. If you spend a little bit more time developing that sample, you could end up with something like this, where, so I'm going to use ARKit to try to position. So those yellow points are given to me by ARKits. There's not that many of them. So I can position my scene. And now I have Yosemite in AR running on my phone. I want to insist on one thing when we talk about AR is it's really hard to talk about while I'm the one presenting and I'm the only one holding the device. But let's say that I want to be on top of Glacier Point right here, and I want to look at Half Dome. If you try to do that with your mouse and your keyboard, you're probably going to have to use the scroll wheel. Then you're going to have to use a right click to position yourself, then the scroll wheel, then a left click to rotate the scene a little bit. It's just not natural at all. What I do here, of course, it's hard for you to realize that, but I just move in a the much natural way possible, and I don't need any explanation on how to navigate the scene. It feels totally natural. But of course, it's the runtime, so I can do other things. So just by tapping on the screen, I'm adding an observer, and I can actually see what that observer can see from that particular point of view, which is actually a lot. That's a pretty nice view for where that guy is. Or I can do a view shed and just move my finger around and see where that observer can actually see or not see. Those are all the runtime capabilities, and I'm just, with that beta program, we're just adding the AR capability. I can actually reduce the scene to fit better on the table. Should have done that at the beginning. So that's a quick introduction of what you can do concerning tabletop in AR using our beta program. As we already mentioned in our presentation, we have several software that are actually consuming already those AR capabilities. So we mentioned ArcGIS, and we also have a research project, which is an AR map tour project. And it's just research and be able to say, oh, I want to look at all the map tour around. There's not that many, so hopefully this one has some interesting point. And so the experience is, if I'm look at flat on my phone is flat, then I have a 2D map of that's basically a typical ArcGIS runtime application. The only thing that you cannot really realize, but it's turning while I'm turning my phone. So that's how you interact with the app, is basically by moving around. And as soon as I lift my phone, I change to now an augmented reality experience. So you'll see something fun in AR is that you never know where the data is going to show up. But the map tour of that particular samples will be in that direction, and then you can get more information of things you can do and how far that data is. And yeah, ArcGIS is another product that is using AR, and the next generation will be built on top of our ArcGIS Runtime AR capabilities. So that's all I had for the quick AR demos using the ArcGIS Runtime SDKs. Back to you, Alex.
Good stuff. Thanks, Adrian. Right, so a quick rundown there of what you'll get when you join the beta program, the sample that's included, as well as some additional work there to show some of the integration there with some of the existing capabilities that are in runtime. Again, you're working with the full suite of capabilities, the sophistication that Runtime provides, and so you can take advantage of that, much like Adrian showed with line of sight and viewshed. But again, of course, there's some additional endeavors there, activity with respect to being able to support applications that we deliver in the future with ArcGIS. So last thing I want to really close with here is just a discussion around integration with game engines. When I mentioned, or when I started this section, I talked about the spectrum, the extended reality spectrum, branching from augmented reality through mixed reality and all the way to virtual reality. And with ArcGIS Runtime, we know that we've got a rendering pipeline that we can build on top of that supports really augmented reality for mobile devices only, right? Things built on with AR Core and AR Kit. What we'd like to be able to do is provide a better, more integrated solution for developers in a game engine style environment, right? So gaming engines provide really premium experiences here for and existing communities for building out really 3D experiences, gamified 3D experiences, but also one thing that's driving their use is building out true sort of premium augmented and virtual reality, mixed reality experiences across the board, targeting things like HoloLens or HTC Vive. So with game engines, they've got their own. There's really two that are in the market today: Unity and Unreal, and being able to build out a solution that allows for really GIS developers, folks to be able to take advantage of their spatial content and capabilities that go along with it in a game engine is really critical for being able to provide a more immersive experience for these really mixed reality, these premium experiences that we're looking at building out today. So what we're looking at right now, and we're currently in progress, we're researching different options for providing really a lightweight API, an entry-level API that allows for access to geographic information, geographic data. And we're thinking here probably raster tiles for display and elevation, features like points, lines, and polygons, as well as I3S data, so 3D content like 3D buildings, 3D objects. But being able to provide a way to access your online data as well as your local data more effectively without having to know the sophistication of the ArcGIS platform. If you're working with a game engine and you need access to data, this is something we'd like to provide a mechanism or really a plug-in or an asset that makes that easier. Of course, game engines already offer an existing system, an engine that really powers a lot of these premium experiences. So we just want to leverage and be able to deliver that data in a way that's most effective. And as simple as is necessary to be able to integrate. Now that might mean that if we're delivering features, we're actually just delivering geometry, and we're allowing the game engine itself to work with that geometry, to render it, to be able to animate it, to apply physics to it, to provide you with a mechanism as a game engine developer to be able to build out the best solution you can. So this is research that we're doing right now. We're actively pursuing this. This is just a quick example here. Now this is relatively old, but this is a public repo on GitHub that shows some of the initial work that we did when HoloLens was first released. This is actually a public project. So if you want to go out to GitHub today, you can download this. It's an older version of Unity, but with a few minor upgrades, I suspect you could probably make this work today. It's actually showing what we did to be able to integrate with ArcGIS Online base maps and elevation services to provide a tabletop experience to gain access to raster tiles for display and elevation, and then also integration with some of the other operations that ArcGIS Online provides, such as geocode, and then be able to display that in an augmented reality experience using a HoloLens headset. So if you're interested in taking a look at what we did here, feel free to go to this site, download the code and take a look. Again, this is active research that we're doing. We are very interested in hearing from you guys if there are folks that are working with game engines today that plan to or need to be able to target those premium experiences or really just a mobile VR experience. And you want to be able to take advantage of what we offer. We'd be very interested to hear feedback on what you guys are looking to be able to do. And with that, I'll pop up the obligatory survey slide, so feel free to fill out the survey with additional info. We always enjoy your feedback. And we've got a few minutes actually for questions. And so any questions we can tackle in the next, looks like we've got about 7 minutes, actually, which is great. So, yes, in the back.
WebVR, likely to be, we're likely to see stuff with WebVR.
You're looking at WebVR, right? So my impression, oh, there you want to grab. So my impression is that a lot of the work that we've seen in WebVR hasn't been up to par yet at this stage. The performance has been challenging, as well as integration has been difficult. So at this stage, it looks like it might just be a kind of a testing effort until we can see some of those improve. That's just my impression. Pascal, I'm not sure if you've got another another take on that?
No, unfortunately, you were right.
Right. Okay. Good.
No,
So
it's still
we'd like
web
to see it get
VR is
better.
still kind of not there yet. We tested. We tried. Also, so there's this new thing called Web XR, which is kind of basically a new abstraction layer by Kronos, I think even. And but yeah, practically it's not there yet. But maybe it's coming.
Yeah, it'd be good. We'd like for that to succeed. We'd like to, yeah, for sure. All right. Any other questions, guys? Yes, down here.
Yeah. So have you abandoned doing like in the Windows environment any runtime for the AR stuff? Like that doesn't get a project, you can be able to put that in there like more on iOS.
I think the challenge that we have there is with just the ability, the capability that the platform has for being able to leverage consistent use of sensors as well as location awareness. So things like an AR Kit or AR Core don't exist on Windows today. And so without that, it makes it difficult to be able to build a really true AR experience. Adrian? Well, so what we have now actually, so with .NET you can target iOS and Android, right? So our Xamarin solution there with iOS actually does include support for AR Kit. We don't yet have support for AR Core, but that's not something that falls on us. It's more about Xamarin support for AR Core. And as soon as we see mature support for AR Core within Xamarin, we'll be able to support that within .NET. The other question there might be working with .NET to target, let's say, a UWP app that runs on a Windows device, right? And so in that case, we're looking for technology on Windows that allows us to provide a better augmented reality experience. And because that's absent today at this stage, we feel like it's not something that we could really provide responsibly at this point. Anything you want to add to that, Adrian? Or you good?
I just wanted to mention that we actually talk with the Microsoft teams and about enabling the same capabilities that they have internally to be able to be exposed so we can consume them, but it's not something that is available yet. So we cannot really target UWP as Rex just mentioned.
Like they're aware of the gap. Yeah, they're aware of the gap as far as we're aware. Well, no, I think it's just a consistent API that developers can take advantage of, right? So, yeah. Any other questions, guys? Of course, we'll be available after the session too. So if you guys have anything you'd like to talk about specifically, feel free to come up to the front. With that, thanks for attending. Hope you have a great rest of the conference. Thank you again. Take care, guys.